Okay, number 13, find the solutions of this equation. So again, I'm going to take the first and the second parentheses and set it equal to 0. Taking opposite, I will have negative x equals negative 12, and therefore x is equal to 12. And then from here, we have 3x plus 4 equal to 0, minus 4 from both sides. I'll have 3x equals negative 4, and therefore x equals negative 4 over 3. So those are the two answers. Number 14, factor each of the following polynomials. And so if it's not factorable, then we need to write that. So the first one, we're going to try to split it up. The third signs, this last signs positive means they're the same. And this means they're both positive. And we have x and x. Two numbers that multiply to get 8 and add up to get 6 are 4 and 2. And so you may want to use FOIL to multiply it out to see if you factored it correctly. For second part, since the variables are not even the same, then we're not going to be able to factor this. So this is actually not factorable or in simplest form already. This one has a number in front of the y squared term. So we're going to try to factor using this crisscross method again. So that's 5y and y. That's the only way to get 5y squared. And it looks like 1 and 1 is the only way to get 1. And they're both positive because of that. And so we're going to check by cross multiplying diagonally. 5y plus y, you get 6y, which is what we got for the middle term. So we're going to actually factor this into 5y plus 1 and y plus 1. That is the final answer. And 15 says write the polynomial modeled by this geometric diagram. So we have 1x squared, it looks like, plus 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 x tiles. And then we have, looks like 10 times 2, which is 20 little tiles. So that's plus 20. And then factoring the polynomial, we're just going to turn this into two parentheses. And so we have the last sign is positive. That means they're the same. And they're both positive. We have x and x. And then two numbers that multiply to get 20 and add up to 12 are 2 and 10. So therefore, you factor this into 10 and 2, and that would be the factorization. Number 16, factoring this expression, we have the signs are different because of the last sign. And then we have x and x. That's the only way to get x squared. Two numbers that multiply to get 21, and the difference is 4 are 3 and 7. And we want a positive 4, so the 7 is going to be positive, and the 3 will be minus, and that's number 16. Number 17, this is a number in front of the x squared. So we're going to use the crisscross spider method again. Then to get x squared, the only way you can get it is 3x and x. And two numbers that multiply to get 2, there's only one possibility, which is 1 and 2. And so let's put down 1 and 2 here. And then just double check. 3x times 2 is 6x plus x. That does give us the middle term of 7x. So we're going to factor this into 3x plus 1 and x plus 2. So that would be the final factorization. Moving on to the right-hand side, we have number 18. Determine whether each value of c makes it factorable. So we're going to just replace c with this value here. So for part A, we have x squared minus 3x plus 10. And if we were trying to factor this, it would be two numbers that multiply to get 10 and add up to get 3. So that is actually not possible. So this problem is not factorable. And for the second one, x squared minus 3x minus 10, replacing the last term with a minus 10. We can try factoring this one. Two numbers that multiply to get 10, and the difference is 3 are 2 and 5. So we actually want negative 5, positive 3, because we want negative 3. So this is the complete factorization. And actually it's 2, x plus 2 times x minus 5. Number 19, the product of two consecutive positive integers is given by this expression, is equation actually right here, which simplifies to this. So we are being asked to factor the equation, so we can actually try to simplify the left side into two parentheses. That will be different signs. Two numbers that multiply to get 12 and the difference is 11 are 1 and 12. So we want negative 12 and positive 1. That's how we're going to get negative 11. So solving this equation to find the zeros are x equals negative 1, taking opposite, and then 12. So those are the actual two zeros for that part. And then B, what are the two consecutive numbers? Since the problem clearly stated that two consecutive positive integers, we cannot use the negative 1. So the only possible answer would be 12. And then consecutive means next to each other, so it would be 12 and 13. So that would be, those are the two integers. Number 20, solving the equation involves moving 9 to the left side first, so we're left with x squared plus x minus 9 equal to 0. We're going to factor the left side into two parentheses. The signs are different. Two numbers multiply to get 9 and difference is 8 are 1 and 9, and we want positive 9 and negative 1 because we want the 8 middle term to be positive. So taking opposite, we have x equals negative 9 and 1. Same thing for number 21. Moving the 9 to the left side, we have 2x squared minus 17x minus 9 equal to 0. We need to factor this using the crisscross spider method again. So we will have 2x and x. That is the only way to get 2x squared. And then let's try 1 and negative 9 because the signs will be different because of that. Let's cross multiply and we have negative 18x plus 1x. That would be negative 17x, which is what we want for the middle term. So the factorization becomes 2x plus 1 and x minus 9. And don't forget we have an equal to 0, which means we need to actually go ahead and solve this. Taking opposite, we have negative 1/2 and 9. Those are the two zeros for number 21. Number 22 is actually a difference of square. So we're going to factor this into 2x plus 4 and 2x minus 4 equal to 0. We have the answers are negative 2 and 2. And finally, the last one, we can factor the left side into x and x. The signs are going to be the same. Both of them are negative. Two numbers multiplied to get 100 and add up to 20 are 10 and 10. So therefore, x equals 10 and 10. And since they're repeating, there's only one answer. That would be 10. It's a double root. And that's the end of this module review.